Hello all. In the season 1 of the 8 episodes that we brought up, most of it was covering basics of noise and vibration, including some of the demos that show up how to set up instrumentation, what to look for, how a basic signal looks like. Moving on for the season 2, or we want to call it as season 2, we will bring up a good number of advanced topics where how the same vibration signatures, vibration measurements could be taken up for better understanding of system, root cause analysis and solving a great number of dynamics problem. So beginning from today's issue, we would bring a lot of this information to you, which is mutually learning. Vibration as a physical parameter is a significant indicator of dynamic response and health of any mechanical system, both linear and non-linear. Most linear responses are assessed and analyzed using output only data, which is also called signal analysis. This involves a good amount of understanding of the equipment under test, its kinematics and operational details, loads and overall system configuration. This approach is mostly used in either machine health assessments like condition monitoring or in some of the root cause analysis and investigative tasks. The other approach of determining dynamic response of any physical system is using a method called system analysis. While the signal analysis relies on output only data, the system analysis approach will either consider many of the forces going into the system or will introduce controlled forces into the system which is under test and will thus characterize the system as a whole. Both the signal and system analysis approaches have their merits and limitations. The signal analysis is a ready approach with the equipment in operation directly considered for characterization without any knowledge of the force going into it. On the other hand, system analysis requires a great deal of test preparation, setting up of boundary conditions, sometimes input from finite element model and analysis, and hence becomes more technically complex and challenging. A combination of signal and system analysis makes a great tool in both understanding the vibration response of a physical system and thus are used on the merits of each case. Now a little more detail into system analysis. Whenever a physical system's dynamic response is assessed, considering the input force going into it, this would be termed as system analysis. This is a classical equation of knowing two quantities, namely the input and output, and thus qualifying the unknown, which is the system under test itself. Two traditional methods exist to conduct a system response testing. The more commonly used method is to use an instrumented hammer as an input device and the outputs of vibration response measured using accelerometers and other vibration or sometimes strain sensors. This method and approach works well when the device under test is smaller and is rigid enough. Test methods like roving force or roving response approaches are used based on the instrumentation resource availability. The more common method of system response testing is using small force shakers that are coupled to the system under test via force transducers as the interface. One or more such electrodynamic shakers are used depending on the size of the test object and its configuration. The drive force is introduced through a connected amplifier which excites the system under test using various types of sources like sine, random and its combination. The responses are gathered using accelerometers or other vibration sensing devices. In both the above approach, as a logical next step, the input forces and output vibration responses are gathered in a systematic method and a data matrix is built up. This data is utilized further to determine the system characteristics such as resonant frequencies, damping and physical shape of the test object for which the determined resonant frequency is to be derived. This whole process as explained above is termed as experimental modal analysis. Beginning with this session, we would bring you insights into the entire process and will make you understand the overall purpose, methodology, process, results and inference. Thank you for watching.